This is the Lineman Channel.
Hi, I'm Travis Christensen with Northwest Lineman College. The installation of ground rods is most important when installing personal protective grounds on a 3-wire system, such as an ungrounded wire delta system or transmission lines with an inadequate or no shield wire. Since electricity favors the path of least resistance to ground, it's important to make sure that your ground rod's resistance is as low as possible. That way, if the line becomes energized, most electricity will go through the ground rod instead of through your body. Now that we know we need low resistance in the ground rod, how do we achieve it? Well, let's go do some tests and find out. Here we have a series of ground rods driven at different depths in the ground. And using this ground rod resistance tester, I'm going to measure each rod's resistance. Our first ground rod is only driven 1.5 feet deep and has a ground resistance of 750 ohms. Our second ground rod is 3 feet deep and has a ground resistance of 440 ohms. And our last ground rod was driven 7 feet deep and is reading 123 ohms. As you can see, the deeper the ground rod is driven, the less resistance it has. Think of it like a sprinkler system spewing water from many different holes or paths. By penetrating the earth deeper, the ground rod provides more paths for the flow of electrons, resulting in less resistance. By doubling the rod's depth, you can reduce the resistance by 40%. But what if you can't drive the ground rod as deep as you'd like? Your next option is to parallel multiple ground rods together. I paralleled the 1.5 foot and 3 foot ground rods and got a resistance of 255 ohms, which is less than either of them individually. If this technique is used, it's important that you create spacing around the ground rods, because as current is discharged into the earth, it displays the same distance around the ground rod as its depth. So if I install 2 ground rods 4 feet deep, they need to be placed 8 feet apart to avoid overlapping their areas of discharge. If I install them any closer together, the resistance will not be lowered. Resistance is also affected by the type of soil the ground rod is driven into. I drove a ground rod 3 feet into sandy soil and got a resistance of 750 ohms, which is more than the ground rod driven 3 feet in the dirt that had a resistance of 440 ohms. I also tested the resistance in swampy soil at the same depth and got a resistance of 122 ohms. So of the 3 soils tested, the swampy soil had the best grounding source. There's no standard level of ground resistance in effect for personal protective grounding. However, finding the lowest ground resistance when installing your ground rods will provide the highest level of protection for you and your crew. For Northwest Lineman College, I'm Travis Christensen. Work safe out there.